All. I'm Siddharth Kaul and I welcome you to Edupedia World. In this video, we are going to take a look at ways to handle errors and exceptions in a Matlab program or in a Matlab application. The video has been divided into 8 sections and one by one, I'm going to go through each of these sections. There are a couple of demos that are involved that I will be showing in the throwing an exception and responding an exception, and other than that all are presentation slides. Let's start with the overview, that is the exception handling in Matlab application. In a Matlab, a program can be created that can be capable of responding to different types of errors. Program can prompt the user for more input, or it can display extended error or warning information, and it can basically do whatever it is told to do. The error handling capability in Matlab allows programs to check for particular error condition and execute the appropriate code depending on the situation. When Matlab detects a severe fault in the command or program it is running, it collects information about what was happening at the time of error. It then displays a message to help the user understand what went wrong, and after that it terminates the command or the program. This is called throwing an exception. Exceptions are thrown both when executing commands on Matlab command prompt and also during executing the program code. Getting an exception at the command window. When there is an exception thrown at the command window, there are several ways to handle it. First is to determine the fault from the error message. Error message is shown by Matlab built-in function and toolbox function are quite descriptive and can be evaluated to understand at least the immediate cause of program failure. The information provided by the error message is sufficient to determine a remedy for the error. The second is to review the failing code. Say for example a function surf. I have called the function surf with no arguments. First is that it throws an error. An error is descriptive enough to deduce that I have not provided the surf function with any input arguments to work with. The error message includes the line number, that is the line 50 in this case for function surf, and message that the input arguments are not there. This line 50 can actually be examined to determine the cause of the error. Third is to use debugger. For longer or looping programs, debugger can be used to step through the code and identify the failing section or from where the failing can start. Debugger will stop at the predetermined breakpoint, or it can go step by step and get the output. When writing out code or in self-written programs, you can catch exceptions and you can attempt to handle or resolve the exception instead of just plain terminating the program. When an exception is caught, you can interrupt the normal termination process and enter a block of code that deals with this faulty situation. This kind of code that deals with such catch exceptions are called a catch block. Some of the things that can be done in a catch block are highlighted and shown here. First is that the information about the exception or error can be examined in the catch block. Second, after examining, the further information, if required, can be gathered to report to the user. Third, the alternatives can be accomplished. Like for example, we can think about alternative methods to accomplish the task that is at hand. If a file is not found, say for example, we can search for other file name or some variation of file name like that. And at last, you can clean up any unwanted side effects of the error and restore the program environment to what it was before the execution. At the end of the catch, you as a programmer can decide whether to keep executing the program or just terminate it. Capturing information about exceptions. In this second section, I am going to discuss how to get information about exceptions that are being thrown. When the Matlab software throws an exception, it also captures information about what caused the error in a data structure called an mException object. This object is an instance of the Matlab mException class. You can obtain the access to the mException object by catching the exception before your program aborts and accessing the object constructed for this particular error through the catch command. When throwing an exception in response to an error in the code, you will have to create a new mException object and store information about the error in that object. The figure here illustrates one possible configuration of an object of the mException class. This object has four properties: identifier, message, stack, and cause. Each of these properties are like fields of a structure and can be accessed using a dot notation. The stack field is an n by 1 array of additional structure that represents one identifying function and line number from the call stack. The cause field is a m by 1 cell array of mException objects, each representing an exception that is related to the current one. Let's take an example. Let's try a basic try and catch statements. Here I have tried to execute the surf function without any input arguments, and I am catching the mException object. I display this me object. The output I get is something shown here. I get a mException object with four properties. First is the identifier that gets populated with an arg in check highlighting the flag of not enough arguments have been passed. This is a message identifier. This is a tag that is attached to an error or warning statement that makes the error or the warning uniquely recognizable by Matlab. This is used in error reporting and to better identify the source of the error. Second is the message that clearly says that not enough arguments have been passed. This is nothing but basic text. This basic text is issued by the program code and returned in the mException object. This message can assist the user in determining the cause and possibly find a remedy for the failure. Third is a stack, which again is a structure which we'll see in the next slide. Then we have a cell array cause, which is empty here. This is when the code catches other exceptions as well. When multiple try-catch statements are involved and there are multiple calls to function that throws an error, I can program my code to catch all of those exceptions. And when the failure happens, all those exceptions will be displayed in this very cell array. Now let's talk about this stack. Let's talk about this stack because this is the thing that we are going to be. This is the thing that we will use the most. Now the stack in mException is basically a structure. We access it using the dot notation. The three fields inside it are file, name, and line number. This is the file where the program terminated. Name is the name of the file in which it terminated, and the line shows the line number where the execution stopped. Here in this case, as we are calling only a single function, hence we only have one entry. This stack is actually an n by 1 array where n represents the depth of the call stack. This field displays the function name and the line number where the exception occurred, the name and the line number of the caller's caller, etc. until the topmost function is reached. All these are stacked in this field, in this field in a form of array of structure. Throwing an exception. This third section, I am going to cover how to detect and throw an exception in a program. There are some basic steps to take care if you are planning to create a program to detect error and throw exceptions. First and foremost is to detect the error. This is done using conditional statements like if and try and catch statement that checks the output of the current operation. Second is to construct an mException object to represent the error. Here it is recommended to add a message identifier and error message string to the object when calling the constructor. Third is to take care of other exceptions that might have occurred or contributed to the current error. Here you can store the mException object for each in the cause field of a single mException that you intend to throw. Basically, here you are combining all the exception causes into one and throwing a single exception to the program. Fourth is to use the throw or throw as caller function to have Matlab software issue the exception. At this point, Matlab stores call stack information in the stack field of mException and exits the currently running function and returns the control to either the keyboard or to the enclosing catch block in the calling function. I have example that will help understand this better, where I have divided the code step by step. So I'm going to give a little demonstration on that. Here I have written a demo script to demonstrate how to do error handling in Matlab. So basically here I have a matrix A that is a 2 cross 2 matrix and a matrix IDX that is a 2 cross 3 matrix. Now first what we have to do is we have to detect the error. So what I'm going to try is I'm going to try index A with IDX. Of course we know this is not possible and it will throw an error. Why? Because IDX is 1 is not a logical array, and second that it is too large for an index and it is too large for a logical array. So now I'm going in the try block, I'm going to index matrix A with IDX. And in the catch block, I'm going to construct an M exception object to represent the error. So in the message ID, I'm going to write the keyword bad index. And in the message, I'm going to write the text as unable to index into array. And in a base exception variable, I'm going to store this M exception object by passing this message ID and the message. Now the third step is to store any information contributing to the error. Again, I'm going to here do a try and catch block, and in the try block I'm going to assert whether the IDX is a logical array or not. So I'm going to use the function isLogical and pass the IDX matrix to it. So I'm obviously going to get that IDX is not a logical matrix, and I will write an error that indexing arrays are not a logical array. So in the catch section, I'm going to catch this cause exception, and I'm going to add this cause to our already existing base exception. So after this try and catch block, I'm going to check for the size. So if the size of IDX is greater than size A, this means that the logical array size is greater than the array size. So this again is an problem, as this is like indexing arrays too large to even fit in the normal matrix. So I'm going to write the message ID as incorrect size, and in the message I'm going to just write the text that indexing array is too large. Again, I'm going to create another exception object for ME exception where I'm going to pass this message ID and message, and again I'm going to add this to as a cause onto the base exception. Now I'm going to throw this base exception by calling the function throw and throwing this base exception. So this error will be thrown. So when I run this, I'm going to, my expected output is I'm be unable to index into array, and I will get the causes as indexing array is not logical and indexing array is too large. So let us run it and check this. So I'm going to change the folder, and I got an array. Now let me see the array. So as you can see, I got the same array. I got my custom error message that is unable to index into array, and I got the causes, that is the indexing array is not logical and indexing array is too large. So this is how we handle errors in Matlab. Responding to an exception. This fourth section we will see how to respond to the exception that has been thrown. In this section I am going to solely talk about try and catch statements. When in a program there exists certain code that can generate undesirable result, it is better to put these kind of statements in a try and catch blocks, whose structure I have shown here in this slide. I have divided the whole thing in 3 points, point A, point B and point C. At point A, the program executes the statements in the try block. If it encounters an error, it skips any remaining statements in the try block and jumps to the start of the catch block or point B. If all operations in the try block succeeds, then execution skips the catch block entirely and goes to the first line following the end statement, that is the program jumps to point C. In the catch block, you as a programmer has power to attempt to resolve the error that might have caused the exception. You can capture more information about the error. You can respond to the information found in the M exception object, and you can clean up the environment that was left by the failing code. The catch block often ends with the rethrow command. The rethrow command causes Matlab to exit the current function, keeping the call stack information as it was when the exception was first thrown. If this function is at the highest level, that is, it was not called by another function, the program terminates. If the failing function was called by another function, it returns to that function. Program execution continues to return to higher level function unless any of these calls were made within a higher level try block, in which case the program executes the respective catch block. To show you some ways to how to handle an exception. So I'm going to take a very basic example where I'm going to take an example where I'm trying to open a image file. So here I have a function read image and I'm passing it a file name. So first what I'm doing is I'm taking out the file parts from the file name. So I get the path, I get the name, and I get the extension. So I'm going to try something here. I'm going to try and open this file as read only. So these are my file opening and reading commands. Now in the catch, I'm going to define a Matlab exception object as me1, and I'm going to get the last segment of the error message identifier. So here the reading can be failed because file is not found. If the file is not found, we can try changing the extension and we can search with .jpg, .jpeg, .tif and .tiff kind of exception. Otherwise, if still file is not found, I can rethrow the error that file is not found. And I'm going to try again with a modified file name. So I'm going to modify the file name and then I'm going to again read this. So again, if I'm not able to access the file, then I'm going to give up and I'm just going to say that I'm unable to access the file and add this to the cause. So this is like one way of handling a very common error, that is unable to open a file, or well, we are searching through directly for the file and something like that. In this fifth section, I am going to cover the cleaning up process that happens at the time of termination of program due to errors. After error handling and execution of function, it is a good practice to leave the program environment in a clean slate that does not interfere with any other program code. For example, like closing any files that the program opened, imported or exported. This will prevent overwriting to the existing file or corrupting some new file and things like that. Second is we can restore the Matlab part to what it was. Third is we can lock or unlock memory to prevent or to allow erasing Matlab function or MEX files. And at last we can set the working directory back to its default if it has been changed, and many such more. For this purpose, Matlab provides the onCleanup function. This function, when used within any program, establishes a cleanup routine for that function. When function terminates, whether normally or in an event of an error, Matlab automatically executes the cleanup routine. The statement that establishes the cleanup routine for the current running program is shown in the first code of line. Here to the onCleanup function, I have passed the function handle of the function that will do the cleanup process. There are basically 6 steps involved in process of generating and activating function cleanup. First step involves in writing the cleanup routine. The second step is where function handle is created for the cleanup routine. Third step is at early point in the program code, the onCleanup function is called where the function handle is passed. Fourth step is when the program is made to run the call to onClean that constructs a cleanup object that contains a handle to the cleanup routine that was created in the very first step. Fifth step is when the program ends its execution. At this point, the Matlab implicitly clears all the objects that are local variable. This invokes the destructor method for each local object in the program, including the cleanup object constructed in the step 4. The sixth and final step is when destructor method for this object invokes this routine if it exists. This performs the tasks that are needed to restore the programming environment to its default. The sixth section is dedicated to issuing warnings and errors. And we will also discuss about warning versus errors. What is the difference between them? Programs can be made to issue warnings to flag and identify unexpected condition during execution of the program. But there is a subtle difference between warning and error. First is warnings do not halt the execution of the program. They do not terminate the program. Second is that warnings can be suppressed without impacting the overall program execution. Warnings are called with warning function and a string text passed to it. As shown here, warning function is called and string of input must be a string is passed in a single apostrophe. One of the usage of warning is shown in function warning example 1, where I am verifying whether the version of software is 7 or not. If it is not version 7, I am issuing a warning saying that the user is using a software version other than 7. Similar to issuing warnings, you can also have the program throw an error and have Matlab terminate it. In a program, you as a programmer can throw an error to flag or highlight fatal problems within the program. You can use the error function to print error messages to the command line. After the error message has been displayed, Matlab stops the execution of the current program. Let me give a very simple example to demonstrate this. Consider the code snippet shown here. This returns the number of combinations of k elements from n elements. So in case if k is greater than n, then this makes no sense, as I cannot choose 8 elements if I am starting with just 4. Same thing has been demonstrated here in code. For function combinations, I take input n and k. I check if k is greater than n, then this makes no sense and program cannot calculate. That is what I write in the error function callback. Same thing I have tested out in the command window by calling the function combinations and passing values 4 and 8. It does throw an error and it also terminates the program. In this 7th section, I am going to show how to change the way warnings are displayed. There are two modes in warnings, and by modifying these two modes, we can change how warnings are displayed in Matlab. Let me explain this with an example. When I enable the verbose warning, Matlab displays an extra line of information with each warning that tells you how to suppress it. Here in the first section of the code, I have disabled backtrace and enabled all warnings and verbose as well, and then ran rmpath with input a folder that is not on path. So I obviously get the warnings that the folder is not found in the path. Plus, as verbose output is on, I get an extra line from Matlab suggesting how to suppress this warning. Here Matlab suggests that to use the warning off to turn off this warning. Using backtrace, we can have Matlab trace to the line where warning has occurred. When backtrace mode is enabled, Matlab displays the file name and the line number where warning occurred. Here in the second section of the code, I have turned on the backtrace and disabled the verbose. So when I get the same warning, I get a hyperlink at the end of the warning saying that at rmpath at 58, this hyperlink will take me to the location where the warning occurred. In this last and 8th section, I am going to summarize how to use try and catch to handle errors in Matlab. There are certain scenarios where try and catch statement can be useful. First scenario can be when you want to finish the program in another way that avoids the error altogether. Second can be then when cleanup is required to stop the side effects of the error. Third is when there are many problematic input parameters or command. So basically the try and catch statement are arranged in block of code under the keywords try and catch. If any error occurs within a try block, Matlab skips any remaining commands in the try block and execute the commands in the catch block. If no error occurs in the try block, then Matlab skips the entire catch block. Let's take an example. It's the one that I showed in this video earlier. Consider the combination function that returns the number of combination of k elements from n elements. The original function is written in the first 3 lines. So whenever k is greater than 0, then Matlab will throw an error. To avoid this or to restructure this, I have implemented a try and catch statement that can avert the error and still generate the output. So what will happen is when k is less than n, then it will find the combinations of k in n. But in cases where k is greater than 0, then instead of throwing an error, it will go to the catch block and find the combinations of n in k, returning the answer in any of the cases. This makes the sequence of input somewhat irrelevant. Even if I part 8, 4 or 4, 8, in both the cases it will return me the answer 70. This concludes our video into error handling in Matlab, and in the next video we are going to take a look into program scheduling in Matlab. So until then, please subscribe and thanks for watching.